Hello and welcome to your virtual Mike 206 experiment. I know that this is not how we were expecting to start the semester, but this is just how we will be proceeding with our day one experiment. So first, I am going to grab my PPE. So far, I have my lab coat, gloves, my hair is tied back, and goggles. Okay. You will also be masked, but I will not be wearing a mask for the purpose of audio quality. Also, I am alone in this room. All right, so the first thing you're going to want to do is wipe down your bench top with some bleach or Clorox wipes. I have already done that to speed up time. And I have already pre-labeled my plates for the experiments. So first off, we will begin with the Ubiquity experiment. So we need one plate and one TSB tube. And we want to examine and make sure that there is no growth in the tube and also no growth in our plate. So this is going to be on TSB agar, which is just a general nutrient requirement for bacteria. This can grow most like common bacteria that we encounter every day. So that is tryptic soy agar, and this is tryptic soy broth. So both have the same nutrient requirements, just one is a liquid and one is in solid form. Okay, so I've already pre-labeled the plates. We have our negative control area. We have, I chose to swab floor, the doorknob, and a marker. And so to keep, so we sterilize the bench top to prevent any bacteria from the bench top going into our plate. We're also going to turn on our Bunsen burner, which you just hook it up and spark flame. And so the Bunsen burner creates a safe bubble so that no bacteria from the air when I open this lid is going to fall into our plate. Kind of neat. Okay. And so first for our negative control, we are going to swab a sterile. So these are in sterile packets already. We're just going to swab that in our negative control area, making sure not to go into any of the other quadrants. And then this will go into biohazard. Okay, so next we're going to swab the floor. I can dip this into the sterile TSB broth. Since these are both sterile, I can do that. So essentially, there shouldn't be any bacteria still on this swab or in this container, since both were sterile. And so just dipping it in the broth helps pick up more bacteria instead of using a dry swab. So I'm going to go ahead, just swab the floor, and then I'm going to put that in my quadrant labeled 4. And then that becomes biohazardous waste. So now this pack is empty. It is also, it can just go into the trash. So I'm going to take another sterile tube. And again, I'm going to dip it in the broth. Now I'm going to swab the marker to see what bacteria we can get from this marker. So I'm just going to roll it around a few times, just like I did the floor. You can be consistent if you want. We're not going to be too picky with this experiment, but if you want to count 3 strokes from each area, that would be more scientifically sound, I guess. And so I want to make sure I'm putting this in the correctly labeled area, labeled marker. I'm just going to roll it around on there. And then that becomes waste. So next, the doorknob. Again, I'm going to dip it. Then I'm going to go swap the doorknob. Now I want you to hypothesize, you can add this to your notes even. Do you hypothesize that you will get more bacterial growth from a plastic marker? Or do you think you will get more bacterial growth from the doorknob? Now I want you to have the materials in mind. This is plastic and the doorknob is actually stainless steel. So I'm going to be right back. I'm just going to swap that. Okay, so now I have my sample from the doorknob and I'm putting that in the doorknob quadrant, again, rolling it around with care. And that is biohazard. Okay, so this is going to be incubated upside down in 25 degrees Celsius. And I want you to think about why we are incubating it at 25 degrees Celsius and not a different temperature per se. That's going to come up again later. And then so I have already taken a pre-sample so I chose to do the doorknob in my tube to see if there's any growth from there. And so I just broke off a cotton swab I had used on the doorknob, and I broke it off into this tube, and I labeled the tube again, just like I did the plate with the date. Instead of my name, I wrote class. And then also I wrote down where I got the sample from, which was the doorknob, and also the temperature that we'll be incubating this at. So I put those off to the side. Now we're going to do our hand washing experiment. So I'm going to take off my glove. And again, I have labeled this with the date, hand washing, and like instead of my name, I wrote class. And then we will be incubating this experiment at 37 degrees Celsius. So first, I have in one section our negative control, which I'm actually not going to put anything on there. I will not use my hand. And then we have an unwashed hand section, and then a section that I will use hand sanitizer on my hands and then wipe. And then after I wash my hands for 15 seconds. I'm not going to wash my whole hand or apply a hand sanitizer on my entire hand. I'm just going to use one finger per each experiment. So first I want to do my unwashed hands. And I'm just going to make sure that I put it in the correct quadrant. And I'm deciding to use my pointer finger for the unwashed hands. So gently without pressing too hard on the agar. Now I want to wash my hands. And then for our second finger, we will be using hand sanitizer. I can just use some lens paper to wipe it around and wipe it off. And then I'm going to want to dry that, the dry section. It's waste. And again, making sure it goes into the correct quadrant, labeled hand sanitizer. Press it lightly. All right, now I will be right back. I'm going to wash my ring finger for 15 seconds with soap and cool water. Okay, so I did that with my ring finger. Now I'm going to make sure that I put it in the correct quadrant. So washed hands for 15 seconds. I also patted it dry with a paper towel because that's just normally how I end my hand washings. And then lightly. Okay. And then again, this is going to be incubated at a different temperature, 37 degrees Celsius. And these are going to be incubated in those temperatures upside down, because if it was incubated right side up, there could form condensation on the lid and drip down onto the agar and ruin our bacterial growth. And ruin our experiment overall. So we don't want that. So we just incubate them facing down, just so you guys know. And that concludes today's experiment. We hope to see you all very soon in person. Again, this isn't how we were expecting to start the semester. To finish off every experiment, we turn our Bunsen burner off. And I won't record it, but you will also be wiping down your benchtop again, just like we did in the beginning, or as I mentioned in the beginning. So before we start our experiment, we wipe down. After our experiment, we wipe down. That is not a COVID protocol. That's actually just a generic, like, microbiological practice, again, to avoid contamination. So that is going to be essential for your experiments throughout this class. Yeah, I look forward to seeing all of your faces, and I know your TAs are very excited to be with you as well. So, okay. I will be posting pictures of the results, probably in 2 days. And also how the plates were labeled. You can view these. I will keep them out during your classes, so you can view them in person if you'd like. And just make sure that this goes into your notes. So it's good practice. So that's it. So yeah, have a great week and take care.